Here the problem is to find this limit but use series to do that. So what does it mean for series? In this there is a sine function, and we've seen now sine function can be expanded as Maclaurin series like that, right? So in place of sine, we can replace that to find the limit. Limit x approaches to 0. In place of sine, I can write this whole series, okay, which is convergent for all x. So x minus x cubed by 3 factorial plus x5 by 5 factorial minus x7 by 7 factorial plus so on up to infinity. Then we have minus x and plus x cubed by 6 divided by x5. Okay. Now you guys notice that 3 factorial is just basically 6. So in place of 3 factorial, I can write 6. Therefore, this x and this negative x is same, and actually x3 by 6 and x3 by 6 is same. They are opposite signs, so they're going to cancel. So what we have actually is limit x approaches to 0, x5 by 5 factorial minus x7 by 7 factorial plus x9 by 9 factorial plus so on minus so on until infinity. And we need to divide all these terms by x power 5. So basically just means that each term here is divided by x to the power 5. So here the first term will be 5 factorial. This is 0 minus x7 when divided by x5 will be x squared by 7 factorial plus x9 when divided by x5 will be x4 by 9 factorial minus so on to infinity. Now we know that x is approaching to 0. When we put x 0, all these terms will just become 0, right? So only term which will be left is 1 by 5 factorial. 5 factorial is 120, so the answer to this would be 1 by 120. Here we have a similar question. Use the series to evaluate. So all these questions we are using these important Maclaurin series here. These are called important Maclaurin series. Okay, these are standard. We can use them to solve other problems. So let's say what this limit is. Limit x approaches to 0, x minus, in place of this, we can write our series, which is convergent for x, absolute value of x less than 1. Here we have x minus x squared by 2 plus x cubed by 3 minus x4 by 4 plus so on up to infinity, and the whole thing is being divided by x squared. Now you guys notice when I open the parenthesis, there is a negative outside. It's going to change all the signs inside. So negative x plus x squared by 2 minus x cubed by 3 plus x4 by 4 minus so on up to infinity divided by x squared. This x and x will cancel because they are equal and opposite sign. So what do we have? Limit x approaches to 0. We have x squared by 2 minus x cubed by 3 plus x4 by 4 minus and so on up to infinity divided by x squared. All the terms in this are to be divided by x squared. So this will be left by 1 by 2 minus x by 3 plus x squared by 4 minus so on up to infinity. X is approaching to what? X is approaching to 0. So wherever I put 0 here, all these terms are gonna become 0. Okay. So only term which is not becoming 0 is first term. So that is equal to half. So it looks like a complicated limit, but we can find it easily using the Maclaurin series. Here we have another example, question number 68 from the textbook. It says find this limit. In this question, we have cosine x, which can be used using this series, Maclaurin important series. And also we have ex in the denominator. That can be expanded as this, your ex Maclaurin series. So let's write this down. Limit x approaches to 0, 1 minus, don't forget the parentheses, otherwise you will mess up the sign. 1 minus x squared by 2 factorial plus x4 by 4 factorial minus x6 by 6 factorial plus so on, divided by 1 plus x minus ex is this expression, 1 plus x squared by 1 factorial plus x squared by 2 factorial plus x cubed by 3 factorial plus so on to infinity. Okay, limit x approaches to 0, 1 minus, when I open the parenthesis, sign of everything changes, so negative 1 plus x squared by 2 factorial minus x4 by 4 factorial plus x6 by 6 factorial minus so on to infinity. In the denominator, 1 plus x outside minus changes signs of everything inside, so every term becomes negative 3. This was 2. Sorry, here I've messed up. This is x square. So this one is x square minus x cube by 3 factorial, so on up to infinity. Let's see. We can cancel 1 and 1. This 1 and 1 can cancel. X by 1 factorial is just x basically, right? That can cancel with this x. So let's see what we have. Limit x approaches to 0. X squared by 2 factorial minus x4 by 4 factorial plus x6 by 6 factorial minus so on up to infinity, divided by denominator, the first term is x squared by 2 factorial minus x squared by 3 factorial minus x4 by 4 factorial and so on up to infinity. I notice all the terms in the numerator have x squared, so I can factor x squared out. What will be left inside? Oh, I have to write still because I have not run the limit yet. Limit x approaches to 0. X squared factored out in the numerator will be left 1 minus, this will be reducing to x squared because x squared factors out, by 4 factorial plus x6 will reduce to x4 by 6 factorial minus so on to infinity. I'm taking x squared out from the denominator too, which is left minus 1 by 2 factorial minus x by 3 factorial minus x squared by 4 factorial and so on. I can divide x squared by x squared, that will be cancelled. Now let's try to put x 0 because limit x approaching to 0. All these terms will turn to 0. Oh, we forgot 1 by 2 factorial here. So what will be left here is 1 by 2 factorial divided by negative 1 by 2 factorial. 1 by 2 factorial, 1 by 2 factorial cancels. We will be left with negative 1. So the asked limit, the answer to that is negative 1. We evaluate these limits using important Maclaurin series. These can be used as facts when you are using them to evaluate other series.